another 5 minutes and then we'll start.
Sure. No problem, sir. Also, here the weather issue. There is a rain here.
In Bangalore also same, sir?
Yeah.
No, okay. I think it is a second consecutive cyclone came in this month.
Oh, just a minute.
I think you are on mute, sir. Please unmute and then you can.
Yeah,
Yes, you can
I'm on
speak now.
call only.
Sure.
Wait, I
Okay.
will. It's now. It's okay. Fine. So, am I audible perfectly? Right. Let me share my screen. I'm not able to share my screen. So, can you make me presenter?
Raju, just make admin a co-host, Dr. Vishal. Please make him as a co-host. I think just give me a minute. They'll do.
Yeah. Now I am co-host. Done. Okay. Fine. So, hope it's very visible to all of you.
Yes, participants comments like there is an issue.
So for this, wait a minute. Okay, fine. So let me switch off my camera. Okay, fine. So shall we start
Sure, sir. We'll start.
or wait for 4 minutes more? We will start at 9:40 if anyone wants to
Uh,
join.
yeah, that's what I'm hoping. I thought so. Just
Fine.
another 2 minutes.
Yeah, fine. We will wait for 2-3 minutes, right? So another participants can join.
Sure. Sir. Okay, sir. We'll start now. Uh,
Okay,
Dr. Vishal, thank you for joining once again. So I'll just give you a brief bio and then you can take over, sir.
sure. Thank you.
Okay. So, Dr. Vishal Rathod is a senior project engineer at CDAC Bangalore and specialized in IoT research and development. And he holds a PhD in computer science and engineering from NIT Surathkal with over 7 years of academic and industrial expertise. Dr. Rathod has led multiple IoT security projects published in reputed journals and conference. And he's also a life member of IET Society, senior member of IEEE, ACM, and IET. And his research mainly focuses on IoT security, congestion control, embedded systems. And he's actively involved in all the actively involved in the workshop and delivered several lectures in a conference and workshops on IoT application protocol and performance evaluation using test beds. Thank you. Over to you, sir.
Yeah. So thank you, Dr. Vinoppa. And I would like to thank the Platicity and AIML department for inviting me in this FDP to give my expertise, knowledge about the IoT especially. So mainly what the things I will cover in this session, because in the morning and afternoon two sessions I will cover. So in morning sessions, what I have decided is that we will go with some brief IoT introductions, that what is required, because before starting the research or any implementation or the product development or anything, right, you should learn the basic things about IoT that I will cover in the first half along with the protocols, right? Few of the protocols if time permits. Otherwise, in the second next sessions, in the afternoon session, what I will cover the protocol, brief introduction, as well as their implementations. That how can you go through. So if the protocol will cover in the first session, then this afternoon session is totally the hands-on session, that what to do about the research, which type of tool you can use to do the research, especially in the application layer protocols, right? So let's start it. So the IoT, right? So IoT is mainly people are using it, right? Broadly, right? Now people, if you see the community, the research community, as well as the industry community, right, as well as academia, people are talking about, I have used IoT, I have built application, I have used this build an application using IoT, right? Anything. But IoT came in 2015, right? Widely popular in 2015. Before that, it mainly are few people knew about this IoT terms, right? But before that, one of the network which is widely used is called the wireless sensor network, and many of us knew that. Many of us already work. Even I have worked my masters. I have my master's thesis on wireless sensor network, right? Because nobody knows that previously only two networks are widely popular, wired and wireless, right? So if we want to do something about the sensor integration and applications like smart agriculture, okay, and industry applications, right, we use some sensors and they are wirelessly connected. So what they are doing, what type of network scenario we are building here, right? This type of network scenario we are building in before 2015. What we are doing, we are deploying various sensors as per our requirement, right? And what they will do, this sensors we use some integrated routing protocols inside that, and this nodes can easily transmit the data, right, to the intermediate node, through the intermediate node to the one of the node which have a internet connectivity. So what, that sensor nodes are dumps, right? That doesn't have an internet connectivity. So what they are doing, they are simply just sense the surrounding environment value, and they will just forward the information, transmit the information to the one of the node which is available at the edge of the node or at the in the network where that node has an internet connectivity, and that node has a capable to transmit whatever data you sense here to the client side or to the you, right? So thing is that many nodes are having just transmit the information to the node which is called as a gateway node, right? And this node will transmit it to the base station. This is a normal scenario before 2015 we are using it. Okay, but the main thing is that what happened to after 2015? IoT comes. Okay, IoT comes, so whether IoT is a subset of WSN or not? My first question to the audience, whether we can say the IoT is a part or subpart of the WSN, yes or no? Anyone from the audience? Okay, so let me explain the IoT. Okay, and then you can give me the answer. And in between, suppose you have any doubt, right? Just stop me and ask your doubt. Okay, don't wait for till the end. Till the end of the session, I will solve all the questions. But in between, suppose you have a doubt, please ask me. So now people are using it. Then what are the problems that people face in a WSN? Let's, I will give you an example, right? We can go through the example and then we decide that whether it is a problem or we have to just go with it. Now say, suppose you build some applications in your backside, you deploy in your hometown or somewhere in the college, right? You deploy one network, wireless sensor network, you deploy 14, 15 sensors there, and those sensors are connected to the gateway, and properly you are getting the data at your mobile or laptop or anything, right? Perfectly the network setup is done. Now you are going to present that system or that network, whatever you build application system, to the client side or to the your HOD or something, that now I'm getting the result, right? Suppose you are halfway, suppose you are going to the client side half, do that is far away from your hometown or from your college, and in between you found that, oh, out of 14 or 15, 4 or 5 sensors are not sending the data properly, right? In whatever you, in the network topology, you say that these networks are not working, right? It's a dead, or something happened to those nodes. What is the, what are the solutions in your mind, right, at that time when you are traveling in between? What are the solution in your mind to resolve that error? Can anybody tell me? Which are the solutions in your mind to resolve this error? Anyone from the audience?
Audience, you can unmute and speak. Like permission is given to you, or you can just type in the chat box.
Hello, sir.
Yeah.
Sir, we can leave the faulty nodes and connect only the working nodes.
Okay, leave the faulty nodes. Okay, we will leave the faulty nodes. Now suppose you go little bit far away, 4 to 5 more nodes are dead. Then now you have only 4 nodes. Suppose you have a temperature, pressure, humidity sensor or soil moisture sensors. Out of that, your application is the in terms of irrigation, right? And now assume that you are your irrigation and soil moisture sensors are not working properly. Then what you will do? Then whether to drop out those nodes will work. The client you are
With the
that won't work, right? Because your system is irrigation, smart irrigation application, and if soil moisture is not detected properly, then how the irrigation network work, irrigation application work? Correct?
Yes, sir.
Yeah. So the now the thing is that okay, fine. What we will do, either you have two solutions, either you go back, right, and again reinstall the few nodes or check that whether those nodes are fine or not. Okay, or what you can do is you can call someone at your place, nearby your hometown or nearby your network setup or college, and tell them that yes, these are the nodes are not sending the data, I am the halfway, please see to it, right? But for that purpose also, the concerned person who you called should know the networks properly, right? Which sensor you use, how to set up. The person should know the properly, right? Then we can get the rectify. Otherwise, as the person whoever speak to me like that as a drop out dot node, right? They can drop out those node and go to the client side, and client is saying that yes, okay, only out of 14 you are getting the data out of 9 or 10 nodes. It would be good because some of the sensors are required and you are not getting the data, right? So either your impression will be down, or you are not getting the contract, or you are not getting the fund or whatever things, right? So in this situation, right, what would be good is that suppose you are able to access those dead nodes from here. Okay, I'm not talking about sensor nodes, I'm talking about the nodes device from here, right? So what you can do is you can access those nodes, reboot, rectify, debug and everything, and you can resolve the error by on the go, or just reaching there before presentation you can rectify it and it will work, right? So for that purpose IoT comes into the picture. So IoT is same type of device we can say in wireless sensor network, right? The device is there which we can attach this nodes, sensors, attach the sensors and actuator, but that is called the IoT device. But if that device is internet accessible, right, you can access through internet, physical device, things which is connected to the sensors are connected to the dead device, and you are accessible to that device, so you can rectify that which sensor is not working, whether is a problem in some interface, or whether the UART is not working, I can change the communication interface or whatever things, right? So that is IoT. That is IoT. So that device is there, right? Device is there, just have the internet connectivity. Through internet connectivity, the devices, physical devices, or we call as a things, can interact or access the information to the other devices or to the gateway or directly. So you can say that if we put the single sensor device inside that, right, inside a wireless sensor network, that cannot be IoT network, right, or cannot be wireless sensor network. You need a properly multiple type of devices inside the network, and then it called the wireless sensor network, and one node should be there to internet connectivity. But here in IoT network, if you put single device which is internet enable, right, you can say that it's a network. Why? Because that device has an internet enable, so I can create as many as network through that devices, because through internet it can talk to anyone. Fine. And we can call this IoT, right, as a sub part of wireless sensor network also, right? But the thing is that in Internet of Things, we call these devices, IoT devices or IoT network, as a resource constraint devices or resource constraint network. Now, why we call as a resource constraint network? Because these tiny devices have a limited amount of RAM and ROM. Now, why is it important? Why it is limited amount of them? See, the thing is that you have a desktop systems or laptop systems, right? They have a motherboard, okay? They have a very big systems with separate amount of ROM and RAM. You can put it inside that. Good, fine. But our devices are tiny, right? And main difference is that those systems, laptops and desktops use microprocessor. Okay, the microprocessor. So microprocessor has a separate space for RAM and ROM, right? You can fit it inside that. But if you think about the IoT devices, which is very small, if you consider the separate slot for RAM and ROM, that device is not compact. That device will be huge, right? So we call as a microcontroller, MCU. And if we see the difference, if you are going to study the processor and microcontroller, see the actual difference is that the microcontroller unit, a single chip we call as a MCU, it contains all the peripherals are inside. Either you taken as a either you consider as a RAM, either you consider as a ROM, either you consider anything peripherals. It will be inside only, which is required to compute and all the things. Now, if we use that, right, so that means any device which have a IoT device or we call as an embedded device, it has a limited amount of ROM in KBs only. They are not going into the MBs only. Why? Because whatever we are building, either firmware or either application or something, it is lightweight. It contains the low footprint. Low footprint means the limited amount of memory. Right. Now, as I saw that they have a constraint in terms of memory. Now they have also constraint in terms of power because these devices are deployed at remote area. Right. So most of the devices have a battery operated or some of the devices you have to give the power supply. Right. Now suppose if you are running a high end application on top of that, right, it consumes too many memories or too many powers. Let's consider the example of your phone. We consider phone as a IoT device because it's internet enabled and so many sensors are there. Okay, now suppose you charge a device or phone 100% and you just put the device in the night without operating anything, just close the application. Still, in the morning, you can find some of the battery percentage drastically 20 or 30 percentage it reduced. Why? Because the thing is that you didn't turn off the Wi-Fi, Bluetooth, and mobile data, right? Why? Because if you turn on the just turn on, keep just keeping on the just keeping on Wi-Fi and Bluetooth, right, or mobile data. That means you see that mobile data means tower fluctuating. It's always searching for your tower, the best network coverage, as well as if you turn on the Wi-Fi, it always even if your router is off, it still searches for the Wi-Fi connections if any the connection is there. Same for the Bluetooth. Correct. So now the thing is that for searching this, right, it needs power, right? To send the beacons, it's need the power, right? And when it will, from where it will consume? From battery only. So now in the morning, you can see that your battery consumption, you charge 100%, but it will be around 30 to, sorry, 78 to 75 percentage. Okay, or around 80 percentage. Correct. So still consume, but if you turn off all the things, you can see hardly 2%, 3%. Right. The thing is that these devices are battery operated, so we cannot run a high and complex application on top of that, which in terms of the those devices are term constrained in terms of power also. Okay. And next thing is that computations. Right. You can't run the complex applications there because these devices have a limited computation. If you run high amount of computations, right, then maybe power consumption will be more, right? So this you have when you are working with IoT or embedded, right, you have to keep in mind that these things, right, these devices are resource constrained in terms of memory and power. Okay, so see, if you think about IoT, right, these three fundamental things are very important. These are the sensors and actuators that many people already knew, right? Temperatures and all the things. But these three fundamental things that IoT network work is you should connect anytime, right? Either you are on the move, either you are outdoor or indoor or inside the house, outside the house, or day or night, anytime, right? You should be connected. Okay, anytime means day or night or like this. Any place, any place means either you are indoor or outdoor, or you are moving, you are traveling, right, at particular location, right? So the thing is that whether you are at any place, you should be connected to the devices. And next is anything. Either you go with the Either you go with the device to device, either you go with the device to the P systems, either you go with the human like you to talking to device, because several sensors you are using the body area sensor networks. So you should also talk to that. So the thing is that anything should be connected. It should not be like that, yes, I have this device, but this device cannot be connected to the, you are not able to connect it because it's not accessible. No. So the three fundamental things at any time, any place, and anything, right? These three fundamental things are in IoT. Now let's take WSN versus IoT. If you want to make a WSN network, because I already told that IoT is a part of WSN, right? It's a part of WSNs. But if you see the, if you want to make the WSN to the IoT network, right? What you can do is, in WSN we have a physical things, objects. You can give it the IP address, right? You can enable the internet, you can run the application and cloud computing, and so many features you can add on, and you will find that yes, your WSN network become a IoT. Okay, so now the thing is that what researchers did previously, because before 2015 or 14, right, people are aware about the WSN and what they will do, the connectivity required, like you have a set up a WSN, I want to connect this network to the internet, so I can put single gateway inside that, and what it will do, I will connect to the server. Fine, but this is the problem here is that if this gateway is fail, there is a single point of failure, right? The single point of failure occur. So what to do? If there is a single point of failure, then you can't access the whole network. So what people think, okay, fine, let me put multiple gateways. Okay, fine, let me put multiple gateways. Now fine, now three gateways is there, I can go through the, I can access the wireless sensor network from any of the gateway. But the problem is that if this gateway is fail in between, or you already send the data, other nodes are already sending the data to this gateway, there may be a chances of duplicate data. Okay, so you have algorithm, you implement algorithm something to discard the duplicates. Then what they think, okay, let me put inside the gateway. Gateway is inside the network and put a cluster like a kind of thing, one gateway and cluster. Okay, so now this is also fine. If this gateway is gone, then fully cluster are, we can't access those amount of nodes. 4 or 5 or certain amounts of nodes are not accessible. So again have a problem. So that's why what they are thinking about, that IoT would be a good network. So a single device has an internet connectivity, we can access it, right? No problem. Problem is that in that network also, if you are not getting internet, right, or there is a problem, right, inside the network, then this device is also cannot be accessible. So problem is that the research should be done continuously to find the solution of those problems. Okay, so now I already explained about what wireless sensor network and already the IoT network and all the things, but still architecture thing is still pending, right? Because without architecture, people are not set up the network. Okay, if you see the WSN network, yes, fine. Wired network, yes, fine. They have a network, they have an architecture. We can use the architecture, we can follow them stacks, right? But the main thing is that in IoT is there is no standardized architecture. There is no standardized architecture till now. When standardize that IoT-A, I will put in the chat box so you can understand that what I am talking about. You can search this, right? IoT-A, which is called the IoT architecture. Still, people are not aware about that. It's not standardized. So anything should be used like TCP. We are using TCP protocol. Means TCP standardized. Standardized means fixed. If you are setting the wired network and if you are setting this type of device through Ethernet, TCP network should be set up. Correct? In this way. TCP works in this way. Standardized protocol, standardized architecture, right? But here, it is not like that. Now, let's assume that you are the one, that simple application you are running, that simple read the temperature value. Okay, and turn on the AC, turn on the AC. Simple application. Now, for that application, are you required complex architecture? No. You can go with the simple architecture, right? Simple layers. But If I have to design, right, a complex applications like various types of sensor, heterogeneous sensors are deployed. I'm including the database part, I'm including the cloud part, sending it to the cloud, I'm doing the analytics. Several services are there. Based on the services, I will do the computation. I have to report to the client, I have to generate the report. Very complex application, right? So whether this simple architecture works for me? No, I have to go to the complex one, I have to go to the different one, right? Now see, in IoT, it is not like that you can either go with the complex application. Like I said, simple application is also there, and like complex application is also there. So what we will do? So one research paper is there which is enabling this IoT, right? In that, what they mention is that based on the conditions, people are following several architectures. These are the several architectures from 3 layer to the 5 layer. Okay. Now, as I said, the simple application. The simple application means you can follow the 3 layer architecture. Fine. The perception layer, or we can call as a object layer, right? We call as a object layer. These are simple layer. We deploy sensors and actuators here in perception layer. Good. Now we set up the network so we can get the data, and on top of that, we are running the application. So for simple application, perfectly fine, this 3 layer architecture. But for my type of applications, right, where is a heterogeneous amount of sensors, a large number of sensors are included, application is included, so many services are there, whether it will work? No. This network simple 3 layer architecture won't work. So what, as time evolve, people are aware about that simple 3 layer architecture can't work. So they're taken as a reference to the TCP/IP 5 layer architecture, and they come up evolving the layers one by one, evolving the architectures one by one, and come up with this last 5 layer architectures. This one, two, three, four, five, 5 layer architecture, which is very perfectly suited for all type of application. Now, object layer means nothing but a sensors and actuators that you deploy. Object abstraction is just getting the data from the objects and passes to the services. As I said, I have developed a complex applications, and heterogeneous sensors are there, and multiple applications is running because I am running on smart city. Let's assume that my application is smart city. Inside the smart city, several subtype of applications are there, and for each subtype of application, several services should be maintained. So it may be possible that some of the sensors, like temperature sensors, send data to the one of the smart city application, temperature sensors sends data to the another smart city application. So how to manage it, right? Because different services are there. So abstraction layer is just getting the data from the sensors, right, and assigned to the particular service management, particular service, right? So temperature data assigned to this service, humidity data assigned to this service, like this, right? So now this services comes from where? The application that we set up. So several applications are running, and each application has a different services which is managed by the service management, and service management now perfectly sending the perfectly setup is done, right? Application layer, service management, object is fine. Now, as an industry perspective, or as I said that you are traveling to outside to demonstrate your application, to demonstrate something, okay, what would you do? Now suppose you are running a complex application, okay, complex application, right? So you have a tons of amounts of data, am I right? Tons of lots of data, because it's not like that you are running only few days, it's running either month, or it's running on what we call as a years, right, or weeks. And if you run on weeks, 10 to 15 days, you will get a GB data, tons of GB data. Now you are going to present your application to the client side, and you are showing the raw data. Let's take an example that whether you're a student, because you are a student or you are a faculty from that audience, I don't know, but suppose you are a student, right, and you are a faculty also. So students can represent the raw data to the faculty, whether faculty can recognize that your application will work properly or not, because Raw data can enter manually by anyone, right? And as a faculty, if you see the raw data, right, whether you are recognize that, yeah, this data belongs to this sensor, this sensor, and application is perfectly getting the data. No, it's not possible, right? To rectify the raw data, it's not possible. What we are thinking about the visualization, right? The visualization. If in the presentation also, if the visualization is good, right, then you can get it attracted by them. Yes, yes, yeah, this is the graph. Now, simple representation of raw data in terms of graphical manner like charts or figures, right? It would be good to take a judgment that yes, the students have an application, build an application, is perfectly working because the data is there, right? So for that purpose, they include the business layer here, right? Because it is important. See, in IoT, if you see the IoT network, read anywhere, lots of amount of data is generated. And if lots of amount of data is generated, then there are several things you need to consider. But the main thing is that how to showcase those data to the client or to the someone who are going to present. So they include the business layer inside that 5 layer architecture. So you can present the data in such a way that your client can understand, right? Your faculty can understand, or anything can understand and get insight from that. Yes, your application is working. So this is the 5 layer architecture till now. Do you have any doubt? Please ask me. Till now, any audience? Anyone from the audience? If you have any doubt, please ask me. Okay, fine. So you don't have any questions, then let me go. In between, suppose you have a doubt, you can put your question in the chat box so I can answer it. Now, now we are slightly moving towards IoT only. Right. First, we started with the basics, that what before IoT, what is it, how IoT evolve, right? What is the problem? What are the problems in WSN that can solve by IoT? And move on to the IoT, that IoT architecture where we explain. Now let's consider the characteristics of IoT. Okay, so these are the characteristics of IoT, which is first characteristic is dynamic and self-adapting, right? So based on the two, dynamic self-adapting and self-configuration, two are perfectly fit in IoT network. Why with these two are important characteristics? Because suppose let's take an example of WSN network. When you going to deploy it, right, a node in WSN, what you will do? You will set up the network. You will configure the node, right? You will configure the node, and then after you will deploy it in the network, and you will see that whether it's perfectly working or not, whether it dynamically adjusts the network condition or not, right? If the network adapts the network conditions, like certainly the temperature is, humidity is there, and then suddenly rain happen, then what happened? Whether your network is perfectly, your node is perfectly capable to adapt a network? No, or not. This is called the self-adapting. Okay, so what we call in WSN is not possible, but IoT, once you deploy the node, because it is internet enabled, right, it can easily start communicating to the other nodes and dynamically adjust the network condition as well as self-adapt the network condition, whether it's perfectly working on particular condition like rain is there, then whether it's enable or not, based on that it will get the data and send it to that. In some situation it is not able to send, so it will change the frequency. Now this is fine, self-adapt the network and all the thing. And in IoT, you don't have to configure the node and deploy it in the network. No, you just deploy it. What happen? It's internet enabled. So based on the communication, based on the other things, it will configure by itself. Okay, it will boot itself and all the things and configure by itself. It's not like that you have to configure and deploy. So dynamic and self-adapting and self-configuring is very important in terms of characteristics in terms of IoT. Now the next thing is that interoperable communication protocol. As you aware about that, We in IoT, we are not like that same manufacturing or same the devices we are deploying. There is a there is no homogeneous devices in the IoT network. It's a heterogeneous devices in the IoT network. Correct. Now, if heterogeneous devices in the IoT network is you used, then it should not be like that this device, like device A has a other manufacturer built this device, cannot communicate to the device B, which is manufactured by another vendor. No, it should not be like that. So we need a communication protocols, right? We need a communication protocol that we can achieve through interoperability. Okay, so interoperability means in terms of any manufacturing device, in term they are not going to the manufacturing by vendor. They are just saying that yes, device is there. I want it supports this communication protocol, which is I can send the data because I am also supporting. So we need interoperable communication protocols. Interoperability should be achieved, right? Each and every device has a unique identity, so no need to worry, and it can integrate it to the any information network which is going to deploy it or which is going to change the application also. It can integrate it into it. Now the main thing is that I want to say that IoT devices or IoT network works on IPv6 address networking schemes. It won't work on IPv4 addressing scheme. Keep in mind that IoT network works on IPv6 addressing scheme. Now, as I already told that yes, IoT device is there, IoT device is there, IoT device did this, IoT device did that. Okay, people are also talking about IoT device. But what is inside the IoT device? Please tell us. Correct? How is it possible that which type of devices, if you say IoT devices, what is inside that? We should know. Then and then we can configure. We can get an idea that yes, this is a device, right? So this is a generic block diagram of the IoT devices. These are the common things that every IoT devices has or not. That already depend on some of the functionality, right? Suppose you go with the some vendors, those who are manufacturing the IoT devices, they have targeted some applications in mind, right? Like Philips have a healthcare division, so they have a targeted application called healthcare. So whatever device they build that by considering the healthcare application. So for healthcare application, some of them or few of them are not required, right? So they devices is kind of that this is generic diagram. So either some of the devices have this or some of the devices do not have. Let's take an example that Raspberry Pi. Raspberry Pi is we consider as an IoT device because it is a Wi-Fi, and we attach the sensors and actuators to the Raspberry Pi and we deploy it. So that full configuration we call it the IoT device. Correct. So likewise, we deployed 5 to 7 hours Raspberry Pi and attach few sensors to the Raspberry Pi through GPIO and deploy in the network. So that device will work as an IoT device. So let's consider Raspberry Pi as an IoT device, and we can go that whether we that have or not this, right? So first is the connectivity. Connectivity already have Raspberry Pi. Either you have a processor inside that, either CPU or MCU. Yes, they already have. Now memory interface, obviously it is there, right? Because we got 8 GB or 4 GB or 1 TB. So memory is also there, right? Either NAND nor if in terms of MCU or DDR1, DDR2, DDR3 in terms of tiny devices which have a left layer. Graphics may not be needed in some of the devices like NVIDIA, who is building the devices. This NVIDIA devices have a graphic because they have a design particularly for graphics application. But Raspberry Pi maybe have or may not be have. As per my knowledge, they don't have. Now audio video interface, yes. Raspberry Pi have HDMI port, yes. Audio jack, video jack. That based on the application, but HDMI port is there inside that. Storage also there, SD card slot, right? Or if you go with the STM microcontroller based device or ARM based microcontroller device or NXP based microcontroller device, then you have a eMMC drive, ROM, EPROM, right? So the thing is that storage is also there inside there. Now the main things comes into the picture, which is called the IO interface. input output interface. Okay, now you already work with the Raspberry Pi also, few of them, or few of them already work with the Arduino also. So both the boards have a GPIO pin. Correct. Now through jumper cable, you are attaching the sensors or actuators to the boards. Right. Now, have you gone through that anything about like this? Like that GPIO is sending the data to the MCU, right? Sending the data to the microcontroller or processor through which communication interface or whatever you are running the application or firmware. MCU is sending the data. Okay, MCU is sending the data to the sensors or to the data to the device or command or something to the actuator. Through which interface it will send? Have you aware about that? Either working with the Raspberry Pi or Arduino? Anyone from the audience? Like take an example that either you Raspberry Pi or like this, you use ultrasonic sensor and you attach the ultrasonic sensors to the GPIO pin of Raspberry Pi or Arduino. And now you are running the command, running the firmware or command uploading the firmware to the device. And then it will send the command to the sensors and sensors will get the reply, the distance and send it back to you. Now, this is the communication. Sending the command to the sensors and sensor will sending the output to the you. Which interface is used to send the data or get the data? Anyone from the audience? Hope you are able to get it what I want to say. Anyone from the audience? Yes. So the main thing is that you have to go through the data sheet. Now, each and every board has some data sheet, right? So if you go through the data sheet, right, the GPIO pin, the black GPIO pin that you attach the sensor to the jumper cable, right? And if you go through the data sheet, you will find that suppose you go with the pin number 13 or pin number 15 or pin number 7, either they work as a UART, SPI, I2C, right? So here these are the communication interfaces, right? UART, asynchronous receiver transmission, serial peripheral interface, internet enable connect, and the CAN. So these are the communication protocols that GPIO pin use. You are not aware about it, but if you go through the data sheet, you will find that any of the GPIO pin we use any this communication protocol except CAN. Can especially for the autonomous automobile applications, right? Either you are doing an applications called V2V, vehicle to vehicle, or we call as a V2X, vehicle to anything. Okay, for that this UART, SPI and I2C interface can be used. So if you are working with embedded, if you are working with hard IoT next times or automobile applications, please see, understand this protocol so you can aware about that, working of that. I'm not going into the deep of that because if I'm going to the deep, right, there is a separate called the embedded part. Now, in terms of logical design of IoT, you can see here the devices, sensors, actuators deployed, application should be there. On top of that, services should be management, then communication should be take care. All things should be management here, management layer. But the most important thing is security, right? The logical design of IoT, security is required. Yeah. So the difference, someone asked about the difference between UART and SPI. So if you see the difference between UART and SPI, both are communication protocol, and you see that where to use asynchronous, like the UART is called the universal asynchronous transmitter, and SPI called the serial peripheral interface. So both use as a the communication interface, but if you in terms of there are several things. So in terms of speed, suppose if you want to achieve higher speed, right, the communication speed, transmission should be faster, you can go with the SPI, right, because it is three times faster than the UI. Okay, and UART is may basically yours used when you are targeting the longer distance the communication, right? Either you communicate like GPS modules. Okay, you use GPS module and you want to communicate it, then it would be good. Now, in terms of clock also, right? If you have something embedded devices which is sharing the clock, UART can't be used because UART doesn't share the clock. But if you want to achieve the the common clock with multiple masters and slave, because SPI is a master slave application, so one master multiple slave, so it would be good, right? So there are several characteristics in which terms of applications, right? Based on those characteristics, right, you can choose any of the protocol, but mainly people are using SPI and UART also, right? So UART, I already said that UART have a very limited things, right, in terms of the physical circuit of the microchip, right, and number of pins in terms of number of pin, number of speeds, clock, right, error handling part, and costing. These are the characteristics that people are checking in terms of selecting the communication protocol. So hope I am able to answer your questions, Mr. Rohit. So it's totally depend on the application, right? Suppose you are having an application in terms of mind, like one master node will communicate with the various other nodes, and those nodes getting the data to the send data to the master. So I would prefer a SPI would be good, right? SPI have a master slave communication as well as higher speed, a higher communication speed, as well as a single clock can be shared with the multiple masters and slave. Benefit is that there. But if you are using a drone application or GPS module which are constantly tracking the devices and this type of application, I would suggest UART. Why? Because that have a longer distance communication. SPI doesn't have a longer distance communications. So, Mr. Rohit, hope am I able to answer your questions? Okay, thank you. So now security is most important part because IoT network mostly use wireless the communication. So wireless communications are prone to error, right? Because you cannot sure that you are getting what we call you are getting a link, your packet is not delivered because of some link disruption or some actual congestion happen or whatever things. So security is very important part of that, and anyone can hack the wireless communication. You get anyone from the means get the data through wireless communication. So now this is a normal typical scenario, right? So you can say that IoT network is doesn't like a simple set up the small network and devices that no, this is the very big picture of IoT network. We can call that as a smart city network. You can consider this. So you have a backbone network which is set up at a one particular location, right, and several other chunks of networks are deployed, right? You can say that the surveillance camera network which is works on Wi-Fi communication, you charge on the health profile, right, the health application which is of the Bluetooth based, the smart water meter, the network which is worked on the LoRa, right, smart waste management network which is works on GSM, right? So there are several other networks, chunks, parts of the network which have a each and every network has a their own gateway and can send the data to the backbone network, right? This is the whole scenario of the IoT network, right? Now in terms of embedded engineer, what you can prospect is that things, devices which is an internet enable, right, that can send the data to the gateway, and gateway has an internet connectivity and can send that to the backend services. If this device is a sensors and actuator, but if you think about the IoT devices, right, so IoT devices itself has the computation, the computation capability, processing capabilities, and it can directly send the data to the backend through internet. So gateway is not required inside that. The local network cannot be required. If you want to set up, you can set up, but it's optional because these devices are internet enabled, so it can directly send to the backend services. Now, why we need a gateway here? Correct. So this is the IoT in terms of embedded perspective, and each and every protocol. Like there are several wireless protocols we use in IoT network: Zigbee, 6LoWPAN, Bluetooth, LoRa, Wi-Fi, and each and everything has a protocol stack. Each and every protocol has a protocol stack, and how this protocol stack works, they have a different explanation for that, right? So as a time constant, I'm not going to read. If anyone wants to um, get into detail, please get in touch with me. Now the main things come into the picture. Okay, the main things come into the picture, which is called which are the protocols. Which are the protocols? So mainly IoT networks is works on 802.15.4, right? This is a 802.15.4, which is a low power personal area network, right? IoT network works on that. So if you see the link layer connectivity, right? That main link layer connectivity, physical layer, we have always have devices, right? That can transmit the data to outside the network. But the link layer, we have a connectivity starting with the link layer. We have several protocols. Now, we already knew that either we have a connected through Ethernet or Wi-Fi or cellular connectivity, okay? And WiMAX is also there. But the mainly, if you think about the IoT devices, they use 802.15.4 as a link layer, also as a physical layer, as a MAC layer, because devices are deploying following wireless personal area network, low power. Now, at network layer, two mainly used protocols are there, two addressing schemes, either IPv4, IPv6. As I said, IoT network follows the IPv6 addressing schemes, and one more protocol is there, which is called the 6LoW, which is called a 6LoWPAN. Now, what is the importance of 6LoWPAN? Once I will cover in the next slide, because I will explain the protocol stack, so you will understand why we require 6LoWPAN. 6LoWPAN, the full form is that IPv6, 6 for IPv6. Low means low power, personal, PAN means personal area network. So low power, 6 low IPv6, low power personal area network. Transport layer, very two well-known protocol, TCP and UDP. And at application layer protocol, you already aware about HTTP, but there are more standardized protocol because IETF, the Internet Aging Task Force, there is a separate working group which is called the core working group, the constant resourceful environment working group, which work on how to develop the how to develop or implement the protocol, standardize the protocol, come up with the protocol 2 that will work on the IoT network. So they will come up with several protocols like CoAP, MQTT, XMPP, DDS, EMQP. These are the lightweight protocol which works on IoT network. Okay, so now let's typical IoT stacks in terms of which are the modes which follow the 802.15.4. So you can see that there is a kind of OSI layer architecture. Stacks are also there. So please consider, I have explained only here, I have only single stacks, but consider that like client server communication, this stacks works on one node. Same stacks can works on multiple nodes also. Okay, now let's start with the radio. Let's start with the radio. Radio means the communication. So the communication should be through 802.15.4, our personal area network. Okay, now duty cycling, right? So duty cycling means here what we call is like IoT devices. I already told the IoT devices are called the constraint devices in terms of power and memory. So in terms of power, as I said, an example of mobile, if you constantly searching for the Wi-Fi connection and Bluetooth connection, it's consume the battery. So we need a mechanism in such a way that the device can consume the less power. So we called as a duty cycling mechanism. So what is duty cycling mechanism means? Whenever the device is ready to transmit the data and device is ready to receive the data, at that time it just wake up, transmit the data, receive the data, and go to the sleep mode or idle mode. So in sleep mode and idle mode, it cannot consume power. But while transmitting and receiving the data, it consumes the power. So by this way, we can achieve the resource means power consumption. We can achieve the less power consumption, which is called the duty cycling mechanism. And there are several algorithms like Contiki Mac, through which you can achieve the duty cycling mechanism. So you can create your own duty cycling mechanisms algorithm as a research perspective. At MAC layer, very well-known algorithm CSMS-CA and CSMS-CD. There are multiple algorithms on MAC layer that can easily fit into this IoT stacks. Now, adaptation layer come into the picture. In adaptation layer, we have a 6-low pan. Okay, now I will cover it. Just wait a minute, few seconds. At network and routing, we have a two. In network, we have IPv4, IPv6, and at routing, one more protocol is there, which is called the routing protocol for low power and low latency network. So RPL means routing protocol for low power and lossy network. Okay, irrespective of whatever application layer protocol used, right? In IoT network, routing layer at only one protocol, which is called the RPL. And I will give you a guidance that if you are planning to do masters or PhD or anything, right? You can done your full thesis on this protocol, full thesis. It can easily work well, right? There are several the researchers or people are working on RPL, right? So you can get as many as topic on RPL, right? Now transport layer mainly two protocol TCP and UDP and application layer. Now the one thing is remaining which is called the adaptation layer. Why we need adaptation layer? So now understand the situations. Let's take an example that you are running an application which use any of this application layer protocol. So it will send the packet to the transport and through the network, right? Routing is done properly and through the network, it will use IPv6 protocol. Now, keep in mind that IPv6 has a minimum byte, right, of packet approximately 108 bytes. Okay, keep in mind that IPv6 minimum packet it can send is 108 byte. And if you see here radio 802.15.4 has a maximum is 127 bytes. Maximum is 127 bytes. Now suppose assume that you are sending the big packet, minimum packet is 1080 and it will pass through this 802.15.4. It can't fit to the outside of the network, or it can't fit at the 802.15.4, right? So what we need is, because TCP has some functionality, right? But what we need to do here, because main thing is that IoT network mainly use UDP as a transport layer protocol. Very few protocols are there that use TCP as a transport layer protocol. If TCP can use transport layer protocol, this problem is easily solved. But if you are using UDP as a transport layer protocol, then how can you fit IPv6 into 128.0.15.4 packet, which is 1280 byte of packet to 127 bytes? It can't fit. You need to fragment the packet, right? Fragmentation of the packet and reassembly of the packet, as well as you have to do the header compression also, so it can easily fit in the things, right? And once you send the chunks to the other side, the same layer will use the reassembly of the packet and send the big packet to the upper layer. Okay, so for that purpose, we need a 6-low pan. What is the task of 6-low pan is that whatever packets come to the top, right, it will fragment the packet, it will do the header compression, and it will easily fit into 802.15.4. When it will receive the other side of it, 6-low pan doing what? Reassembly and send the big packet combined to the top. Right. So that's why the 6-low pan is needed. So this is the explanation of each and every layer. I'm not giving the detail. And if you see the routing layer, how it works. So if you see that once application is sent, the routing layer knows that the address of the same next node or intermediate node to send the packet, and it will go up to the network layer only, and at last it will go to the destination. There's a normal routing scenario, so I'm not now two most important thing right? You already aware about the architecture, which architecture follow. You already about the logical design characteristics, right? Stack protocols, how it works. Okay. Now the main thing is come to the picture. So suppose you want to work with IoT, right? You should aware the two important thing. One is the communication model, which communication model you want to set up inside your network. And one thing is that communication patterns. This true important thing required to understand before you start working in the IoT network. Communication model and communication patterns. These two fundamental things are very important. You should aware about it. So let's start with the communication model. So there are several communication model. First is a request response communication model. Any one of you from the audience knew that? Just give me a answer that which protocol that you know which is works on request response communication model. Any one of the protocol that you know which works on request response communication model.
Hello, good morning, sir.
Yeah, good morning.
It's MQTT.
No. Anyone else that you know? I'm not talking about IoT, right? I'm not talking about IoT communication protocol, the previous that you already worked. Anyone from that the communication protocol which works on request?
TCP then.
No. Rohit is gave the answer which is called the HTTP. Correct. Right. So HTTP is a perfect protocol which works on a request response communication model. So what like we are the common example is the browser. Okay, just hold a minute. Uh, one important call came. Okay, so HTTP. So like common example is browser. So what we are doing is in browser we are typing something which is called the URL with the URI concept. URI we call which contain the URL as well as query and all the things. And what we are sending, we are pressing the enter. Once you press the enter, we are client side. The browser is client, right? We are the client. So what client is sending the request. When we said press the enter, it's sending the request to the server side. Right. Now, what server will look into it? Once the server will get the request, it will break down the things. URL, okay, URL is this. Okay, this is a URL, then this is a query. So it will go to the resources. It will go to the resources. It will find the representation of the resources. And once it will find the resource and representation, it will prepare the response and send it to the you. Okay, in the browser, you can see the website. This will be very quick, right? But this is a common fundamental thing. The request response communication model and browser through browsing, it's a very common example that people are using. And HTTP is perfectly suitable for request response protocol. Good, fine. But what we call as the next communication protocol, which is called the publish subscribe communication model. So we can say that here request response communication model HTTP is a good protocol, but when I explain the application layer protocol which is specially designed for IoT network, at that time I will explain that whether HTTP would be good in IoT network or not. Now the publish subscribe communication model. Okay, so publish subscribe communication model, anyone have an idea that the common real-time example I'm asking? The common real-time example that you know it works on this model. Anyone from the audience? You are very well known about that daily life, you are using it. YouTube. All you are following YouTube, na? Yes or no? You are using YouTube or not? Audience?
Yes, sir.
Yeah. So YouTube works on this publish subscribe model. See, you are using, yes, you are liking some, you just like some channels. Like suppose I am having a channel, right? I have a multiple channel. What I will do, what I will do, I will have multiple channels. So I will publish the video. So I become a publisher. I will publish a video in gaming channel. I will publish a video on tech channel also, right? So now some of you members are good in my tech channel. Some of you are good member interested in my tech channel. Some of you are good members interested in my gaming channel. What you will do? You like the channel, right? So you are the subscriber. So what subscriber will do or consumer will do? Subscribe my channel. Okay, so some of you are subscribed to the gaming channel, some of you subscribe to the tech channel. Good. Now, gaming and tech, what is it? It is called the topic. It is called the topic. So, subscribe to particular topic. So now the thing is that once you subscribe, you will get the notification only those videos, right? Only those videos which are published on tech, not on game. Correct, because you have subscribed that. And who will manage all the things? In terms of real-time example, it is YouTube. And in technical terminology, we call as a broker. Right. So broker knows each and everything that which how many subscribers are there for one particular channel, right? And who subscribe to this particular channel, who subscribe to other particular channel, right? And mapping all the things is maintained by the publisher broker, right? And one of the protocol that madam already called said that not called said that MQTT. So MQTT follows the publish subscribe communication model that I will explain. Now, same terminology, publish subscriber, the publish consume, but the communication model name change, which is called the push pull. Push pull here, instead of broker, we have a queue here. So what publisher pushes the message to the queue, it will maintain in the queue, and whenever the subscriber or consumer needs, it will pull it from the queue. Good, fine. Now tell me the communication, tell me the real-time example that follow push-pull communication model. Anyone from the audience? Similar concept, publish, subscribe, publish, consumer, but instead of broker, here the picture comes with the queue, right? So the queue is just buffering the packets. What queue will do? Just buffering the packet. So later you can watch it. You can pull it from the queue and watch it. So real-time example.
WhatsApp messaging or simple text messaging?
WhatsApp messages, but you will get notification immediately. It's not like that whenever you required, at that time you can pull it.
But in text message center, the messages will be preserved, na, sir, until
Yeah,
we are
message
in
preserve.
the.
But the thing is that what I'm saying that whenever you required, at that time you pull. Now suppose it says the WhatsApp and text message, it's delivered to you. Once they will send, it will deliver to you. Now it's your choice to see or not. But it is kind of like features message in the buffer, right? Message
Okay,
in the
then
buffer.
our mailboxes may be best example for
Yes,
this, sir.
mailboxes will be the best, correct? But one of the common example, why I am relating to the this examples, because you can get an idea. Mailbox is a perfect example, right? It can store in the message, but again, it will deliver. It will deliver, but you can watch it. Now, let's take an example of Instagram and Facebook. Instagram and Facebook, what if you are watching, you are facing, you experience this scenario or not, but I face an experience. Now My friend already posts something, right, on Instagram and Facebook, but or Reels post, but I didn't get notified until I will scroll down too many times. Once I will scroll down too many times, it won't visible until I click on new reels come into the picture or new feeds come into the picture. When I click it, what it will do? It will scroll back to the top, and then new feed will become new reels, new post, all the things will be come into the picture. Same in the LinkedIn also, right? So no doubt mailbox you can say, but my idea is that in push pull the storage is inside the mail, storage is inside the box, in the message box, in the WhatsApp. It is not like that the message is not delivered until you say yes, now delivered. It is delivered to you and then you can watch at your time. But in Facebook, Instagram, and LinkedIn, someone is posted, it's not visible to you while you are watching it. Okay, I am not saying that your application is closed. While you are watching it, or open the link, Instagram, you already open it, Instagram, Facebook, or LinkedIn, anything, someone is posted, you will click on the top new post or new feed or something. Once you click it, then it will pull it from the queue. It's not like visible to you directly. So this is a common example of push pull. Okay, hope you can understand, madam. Yeah. So the next thing is
Yes, sir.
exclusive pair. This is a very common example. You all of you done the socket programming. The same kind of programming is that. So before the client server start communication, right, the persistent connection is needed. So first you set up the connection properly. Once the connection setup is done properly, then you can the persistent you using this persistent connection, you can do the communication between client server and then close the connection. So mainly TCP is used in this exclusive pair communication model. But the main thing is that while you are following the request response communication model, the REST based architecture should be followed. Okay, that HTTP is already following. So whoever, whatever the protocol, right, whichever protocol you are using as a request response protocol, either you offer HTTP or any other, right, or the IETF is designed specialized protocol for this, it should work on REST architecture. REST architecture means certain principles that how it works, the API should be followed, standard should be followed, right? This is called the REST API, this work-based communication API. Now, I'm not going into the deep of this deployment techniques, but the third important thing, except the communication models and patterns, right? Deployment technique is also things. So there are various categories. So main deployment techniques will come into the picture. There are various levels, right? Level 1, level 2, level 3, level 4, level 5, level 6. Based on the complexity of the application that you are building, you can use it. Some of the applications, like I said, that simple applications, get the data and of temperature sensors, and based on that turn on the AC. So for that type of application, you don't need anything high end devices like cloud or anything. Okay, you just get the data at local laptop or something, process it, store the data as a local only, no problem. No the vast amount of data you can get and process locally. All the things, the database can be maintained locally and all the things, right? Fine. But if in terms of complex applications, if I application like heterogeneous devices, 15, 16, or 20 heterogeneous devices are used, okay, and if these devices are has to send multiple types of data, so many amount of data, so what should do, right? So the thing is that based on the application decide, right? Sorry, based on the application, you should choose the deployment strategy. So there are several deployment strategy, which is called 1, 2, 3. So it's divided into two part, which is called local. So for simple application, you can go with the local. If you have a complex application, based on the complexity, you can go with the level 2, which is as a cloud part also. 3, 4, 5th, 6th. Up to 6 levels are there. This 6 level is a very complex application. You have a multiple nodes, heterogeneous amount of node. You need a centralized controller for that to coordinate with it. You need an observer node which can observe the things at the client side also, local side also, at the cloud side also. So very complex application. So the level of deployment strategy also is important in terms of the IoT. Okay. Then last common thing is the communication pattern, which is already standardized. It's RFC 7452. You can think the terminology is different. The RFC 7452 use the terminology which is called gateway, cloud, device, and device. This type of terminology used. I have used a simple terminology which is called the IoT device and systems. So there are mainly four communication patterns that IoT device follows. First is telemetry, second is inquiry, third is command, fourth is notification. Inquiry and telemetry and notifications are simple unidirectional, but inquiry and commands are bidirectional. So if we relate this to our real life example, right? Telemetry is simple, like device, whenever device have a IoT device sense the surrounding environment value through sensors, it can directly send it to the systems, notify the systems. Okay. Someone is asked what is the difference between IoT level 5 and level 6. So level 5, you can see that there are multiple nodes in both the nodes, but there is a coordinator inside that, right? So coordinator is there is a only difference between the coordinator and centralized controller. So coordinator, what coordinator is? The coordinator is simply managing the things, right? It is not giving the command to the nodes. It is not giving to the commands to the nodes that yes, you have to do this because the condition is changed in the network, please send according to that. No, it just coordinate means send the data from here to here properly way data is getting or not. But in IoT level 6, centralized controller is needed. It will control the nodes also, it will control the cloud side part also, as well as it control the centralized controller also control the services part at both the end, right? To turn on the service, to turn off the service and all the things. In level 5, it is not like that. Hope I'm able to answer your question, Priya. Okay, so if you have any doubt, just post it in the. Okay, fine, thanks. So in telemetry, what devices just sense the surrounding value. You deploy the temperature sensor, you deploy the pressure sensor, it will get the data and send to the systems or gateway. Fine, this is called telemetry. Now, let's understand the notification. All of you are aware of the WhatsApp notification, Facebook notification, LinkedIn notification. When there is a change in the idle condition, now your WhatsApp is idle. You are not getting any messages or something. Status is idle. Okay. Once the ideal condition status is changed, ding, right? Something is changed, right? Someone is send a message, your idle condition is changed, and you will get the notification. Yes, your idle condition change. Your WhatsApp getting a message from your friend or something, right? Similar in IoT. My IoT network is perfectly running fine. Temperature is perfectly ambience. Let's take an example of temperature sensor. Temperature is ambience, perfectly working now. Suddenly, my classroom or in room, I am only one sitting, but some meeting going happen. My team member came 5 to 6 team members, and they are sitting here. Oh, now the thing is that temperature sensor, whatever the single person, the AC, right? The temperature of the AC should be on 26 or 27, which is I'm single. Fine, but now 4 to 5 members will increase. So total in room, small room, 6 to 7 members are there, and the 27s get hot, right? Humidity will be increased. So what will do? Temperature sensors, right, or systems, or has to notify that, correct? Now the condition is changed. Okay, please send me the updated value so I can work based on that. So system notify the device that yes, condition is changed. Now the temperature is this 27 temperature is want to work, says the temperature value and send it back to me. Correct. So notification has to be sent. Similar way, inquiry. Right? Inquiry. Now, inquiry and command, we understand based on the common example that we are every day we are facing in our daily life. While many of you are traveling by bus or railway, right? Train, and someone is train or bus is late, what you will do? You don't know about the, if you are new, you can go to the inquiry counter and you are inquiring about what? Inquiring about what? When will the bus come? At which station will bus come? Right? Train is delay or not? Like you are inquired. So device is inquired. You are device. You inquire to the system, right? And the system will respond. The person will respond. Likewise, device. Now let's the same example. I am sitting alone for last 1 hour, but it may be possible that something is missing. So what device will do? Device will inquire to the system. Oh, is this perfectly all right? Or is there any condition is changed? Right? And system is replied, no, the condition is idle. You can send as much temperature is there, no problem. Right? So device is inquired and system will respond that yes, everything is all right. In terms of commands is different. Like the professor who are the students, the professor will give you command, yes, I want this deadline. This is a deadline for the assignment. I want your assignment should be done within this deadline. You should submit. Right? And you are submitting the assignments to particular deadline. Similar way, system is giving the commands. Yes, now every 2 hours instead of now 1 hour or 20 minutes, because the condition is not changing properly. So instead of 20 minutes, now send the reading mean after 45 minutes. Okay, because frequently reading means the power should be consumed more or anything could be consumed more, but last for 1 hour the system is not updating properly. What you can do, just update. The command is given to the sensors that device, yes, now instead of 20 minutes you can send me reading after 45 minutes, and the device is they respond the things, yes, after 45 minutes I will send. So these are the communication patterns, telemetry, inquiry, commands and notifications that mainly IoT system follows, right? And now the thing is that if you go to the RFC 47452, you will understand that this scenario is explained using the gateway and device and cloud. Gateway and cloud become the systems, and end device become the IoT device, right? And they create several scenarios and explain properly. So it's standardized. So if you consider any IoT network, it will follow any of this communication pattern, not beyond that. Okay, so what the most important thing is, right? We learned in the first session is, first, before IoT, I will revise it. Before IoT, WSN is there. Which are the problem in WSN? How IoT resolve? Then we go with the architecture part, right? Definition of IoT, the fundamentals of IoT, characteristic of IoT, block diagram, generic block diagram of IoT. Then we go about we went through the protocols, then how the stack should work, correct? Then what we'll go, then we went through the three most important fundamental things: communication models, communication patterns, and deployment strategy. So now now it's 11. Let's take a questions because the application layer protocols are there. So what in the second session, 2:30 to 4, what I will do is I will explain the two most important protocols that widely used, CoAP and MQTT, right? And I will show you the demonstration of those two protocols. Okay, so let's take a questions, any one of you have, and then we will meet on 2:30. Right, sir? Bhimappa, sir?
Yes, sir. Yes,
Yeah.
I'm here.
So,
Okay.
any question?
Student participants, if any questions are there, just type in the chat box, or you can unmute and speak. Sir, one question from my side, right? So generally we are talking about IoT, right? There was one session which basically discussing on federated learning. So is there a possibility is there a possibility of using federated learning based IoT devices?
Yes, you can. You can use federated learning based IoT device. Even the AI/ML now, because this workshop is on AI/ML and IoT both, right?
Yes.
So you can use AI/ML part also. The main thing is that where should it fit?
Okay.
right? Where should it fit? So devices can be federated learning based, right?
Okay.
So federated the learning nothing but a ML method only, right? So what it will
Yes.
do for
Kind of.
it will work on the edge device like gateway or something. It
Yes,
won't
yes.
work on the end device because end device are resource constraint. And if you run this model, right? So this model will either AI ML or something, whatever thing federated learning, it will train the model, right? Train the data set, right? You have to train the data, so it will run on the gateway side or some of the device which is having a high computation power. So for that, either you run this federated learning or ML or AI or whatever things, it will run on edge device, gateway, either cloud side or your system side.
Okay. So another last question. So you were discussing about this public subscribe model, right? Especially communication
Hmm.
model. So when
Hmm.
we go to this underwater acoustic communication, right? And
Yes.
UAV is typically used in underwater to just to navigate and see
Yes.
the scenarios, right? So there
Yes.
also the major challenge. There also these devices will be very small and they need to
Yes.
communicate. For communication, basically, they can we use these models or is there any other requirement?
No,
Usually.
no, no. Underwater is different.
Ah,
Underwater is different. If you use IoT
the communication
devices,
will.
so yeah, so
Ah,
IoT device underwater is different than the network things, right?
okay.
Different network architecture is there, different communication protocol is also there because see, it is going under sea only,
Yes.
right? And the thing is that to communicate to the sea, so if you go through the outside net like the Europe or something, they have a
Mm,
boy boy set up at particular location, like
okay.
some what we call that the we call as a boy what is a floating device which have a like simple straight line and like roaming here and there. So
Yeah,
that
it's a
have a
kind of
communication.
boat, a small boat which roam around
No,
and
no,
connects to
not boat,
the
not boat.
ah,
Like device only, like
device.
deploy,
Okay.
finished.
The deployed
Uh,
devices.
Deploy device just floating on the board or the water. So
What?
what they
Okay.
did
Okay.
is a BOE. They have an antenna inside that. So they have
Okay. Okay.
deployed in certain locations, right? And whatever device is inside that, right, underwater, that will
Mm,
communicate to the this boy. So
okay.
now
It
that
acts as a
device,
kind of gateway.
yeah, that is different
Ah,
communication protocol. That is different architecture.
okay. 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 Fine.
Hmm.
Thank you, sir.
Okay, and one uh,
Please go ahead, sir.
yeah, one question is there here. Let me check again.
Okay.
I saw that. Can you please specify? Dr. Anushka is asked. Can you please specify in what condition WSN
I,
that you don't need several amounts of data. Generation is not there. Some sensors you are getting the data and you have to manipulate for simple applications. Fine, fine. That is what WSN can be used. Okay, but in terms of IoT, right? In terms of IoT, right? What you can do, where you can use it, when you deploy the network in the remote area, and the main thing is that you have to get your remote location data. You want to get it in wireless sensor network, you can get it, but for specific applications like standalone applications that you are sending their devices there, you can hardly work. But if you are constantly monitoring those devices, IoT applications, right, that IoT would be better, my thing. Complex device. And in terms of embedded applications, like now WSN is not widely used. Very frequently tell you the WSN is not widely used. People are following IoT only because WSN is a part of IoT only, we can say that. Okay, so mainly people are using IoT. So it may be possible that IoT can get the data. You can't access the device. See, frequently said you can't access that particular device in the network. If you want to access it, you can use IoT network. If you don't want to access in particular application, go with the WSN. So hope I'm able to answer your question, madam. Madam, is
Hello.
there any questions?
I think there are no questions, sir. Again, uh,
Okay.
Hello, I'm audible. Dr. Vishal, I'm audible to you.
Yeah, audible.
Okay. Thank you, sir, for joining. And anyway, we'll meet again in the afternoon session.
Yeah. So 2:30, what I will plan is, because I am not covering so many protocols because of only 1.5 hour time, what I will do is I will go through uh, two mainly protocol, right? Application layer protocol. One is request response, one is the publish subscribe, and then I will show the demonstration of those two protocols.
Demonstrate. Okay. Okay. Sir. Okay. Thank you.
Okay. Yeah. Thank you.
Good.
Bye-bye.
Okay. Participants, just one announcement. So there will be a feedback form at the end of the day, maybe in the second half session. It will be shared over email. So, or in the chat box, you can just give. That's one thing. And second, we'll start again session at 11:30. So till then, you can stay or can come back at that time. Thank you.